A horizontal 20 Newton force is applied to a 5 kilogram box to push it across a rough horizontal floor at a constant velocity of 30 meters per second to the right. Determine the magnitude of the force of friction acting on the box. Well, as always, particularly with these forces problems, it's a really good idea to draw a picture of what we have here. So, let's take a box. We'll draw it on a surface. And let's figure out what some of the forces acting on this box are before we even really begin. Well, we've got the force of gravity pulling downwards on the box, and canceling out the force of gravity acting in the opposite direction is the normal force. It sounds like we're pulling with a horizontal force of 20 newtons. And we can tell that there's friction because it's a rough surface and because we're being asked to calculate the force of friction. So that's going to oppose the motion, or oppose that 20 Newton pull. The object is moving towards the right with a velocity of 3 meters per second. Determine the magnitude of force of friction acting on the box. Now, one of the important things to notice here, anytime you're reading a forces problem and you notice this phrase, constant velocity, you should circle it and star it. It's very important because if it's moving at a constant velocity, that indicates that the net force is zero. It's in equilibrium. If the net force is zero and we're pulling to the right with 20 newtons, what do we have to be opposing that with to bring it down to a total of zero? Well, we must be pulling with 20 newtons in the opposite direction. And so the force of friction is simply 20 newtons. 77, 78. Calculate the weight of the box. An important idea here is, when I say weight, what are we actually looking for? Well, remember, weight in physics is the force of gravity. So we have an equation for the force of gravity. Fg equals m times g. The mass of the box is 5 kilograms. G represents the acceleration due to gravity, 9.81 meters per second squared. Multiply the two and you get a value of 49.05 newtons for the weight or force of gravity of the box. Lastly, calculate the coefficient of kinetic friction between the box and the floor. Well, one of the nice things about this problem is there's only one equation that we've covered this year that has the coefficient of friction in it. That's Ff equals mu times the normal force. Now, we just found the force of friction in 76. It's 20 newtons. We're solving for the coefficient, which just leaves this normal force. So we need something to plug in here. Now remember, as long as this object is normal force is the surface pushing directly upwards. And as long as the object isn't falling downwards through the floor, it's equal to the force of gravity, which we actually found in the previous question, 49.05 newtons. So what we can do here is just take that value and plug it in as the normal force. Throw these into your calculator and you get a value of 0.41. Remember, the coefficient of friction does not have units, and so we've answered our question.